Hey guys, this is Ayush. This is my first video guide for ECS 36B, a review of classes and objects, everything you need to know so far. So let's get started. So right here, this is a 150 line program. Here is our class. It has protected variables and public member functions. Now we have all our member functions defined throughout here. And then we have our personal function, which is not a member function. It's actually just our own function. And then the driver code, of course, which has a couple sections. So, by the way, quick tip, whenever you're trying to understand like any program, always just look at the driver code and then it'll make a lot of sense. It'll walk you through how a program works. So anyway, this is our first part of our driver code. We're going to be calling our personally owned function, which is this one, not the member function, our personal one. And what this does is it creates an instance of the class or an object. So, by the way, this will auto initialize, and the reason the auto initializes it width being 2 and length being 3. Sorry, by the way, this should say actually length. And the reason it auto initializes is because if you go up to this is an auto initializer. Right here there's the declaration for the auto initializer function. Here's the definition. It has to have the same name as the class, and what it does is that whenever an instance of plane is created, the auto initializer will set the values to these. So really understand the syntax for that. And that is why this will have a length 2 with 3, I think. Anyway, so now we have the getter function. This will store the values in. So we want to know what the values are because we can't directly access them because they're private. So the getter function basically stores the class's object's values into these variables, and the way that works, we take in references, and then we set each of those references equal to the length. By the way, you can say this pointer, you can say that, that basically means that we're referring to this object or this instance, and that, of course, that's a good idea to have that. I just chose not to include it for this specific function. But what this does is that this pointer says that we're referring to P1, so P1, we're referring to that. Now there's that function. So also note that whenever a function creates an object, that automatically gets deleted after the function is done. So that's why we can call this function 2 times and it can create 2 objects of the same name, because the first time we call it, P1 is deleted after we're done. The second time we can again create P1. Now section 2, creating and destroying objects. So this is done from inside int main, which is a little bit different than a function's auto deletion. Here we have our setter. Setter is already covered. Now here's our deleter. So what the deleter, how it works is that if you go up, by the way, my code is going to be available on, I'll provide a link in the description for this code so you can actually go through it while looking at my video. Okay, so this is the deleter. So that that's the declaration, and then we have the Oh, sorry. Actually, yeah, we don't have a definition because it's defined right up here. But yeah, that's all you literally need for the entire definition to delete an object. So now this is a function. Whenever it's called, it will delete the object. There's that. So now I'm going to have a section 3, a pointer to object. So we're creating a pointer. It's pointing to an object. Now, the way you can use that is that there's a lot of stuff you can do with pointers, like smart pointers, shared pointers, unique pointers. That's why you might want this. This is something that's kind of useful to do. And the way you would treat the pointer is you'd basically treat it the same way as any other object. So like with a normal object, I can just do dot setter. With a pointer, I can literally, and like normal object dot getter, normal object dot member function, well, A, member function B. With a pointer to an object, it's the same exact thing, except you just do up like that. Instead of dot, you have that. So then we can, of course, delete the pointer like that, and then that's basically the same thing as saying saying that. This is like the normal way to delete a pointer in general. This is the way to delete a, the what delete, well, actually what the pointer is pointing to, the object. Now section 4 and 5. So we have our plain P4. We're declaring it so it's auto-initialized, but then we reset the values to -1, 4. Those are just some random values I gave in. And then, okay, this is a little bit more tricky. We want to create a plain 5 that's a copy of P4, so we can use this duplicator function. Now we have to do P5.duplicator, because if we just call a member function without like an object, then the compiler will be like, what object are you talking about? So yeah, we pass in P4 and then we do P5 dot. Now, if we look at the duplicator, right there. So that's the definition. By the way, the declaration is right up here. So the duplicator, it will create an object and it will get the original's length and width. These two are member functions of the original one, so you can actually call those orig.getLength. You're referring to the original's protected variables, and then you can store them into here. Now that you have these two variables stored, you can do plain p5.setter original length, and then original width. So that's creating a copy of that. Now you can, in section 6, so this is another member function which allows for an incomplete, so let's say you want to initialize a plane, but you don't want to, you're too lazy to put in the second parameter, so you would just want to pass in one parameter. There are two ways to do that. One is to just call the setter function and have it in the setter have you can of course have a default parameter like that in the setter function. That's one option, but the other option is to have a member function which will call another member function, which is also a pretty useful thing to know how to use. So here, let's look at setter incomplete. Right there it is, and the declaration is up there. Remember that you need a declaration for every single member function in here. Anyway, so setter incomplete, it takes in that and it calls another member function and adds an extra parameter. So then we're doing setter, now it calls this, and then this setter sets the values. So okay, now this part is pretty useful, a vector of specified copies of objects. So if the reason why you would want a vector of objects is because it's actually really, really useful. Here, let me show you an example. Let's say you want a whole bunch of objects. Then you'd have to declare each of them individually, and imagine typing this line like 100 times. That's not comfortable. So you can have a vector, and the vector will be a vector of objects. And then here we're initializing it to hold copies of P4 and P5. So, and of course, push back a copy of P6. And I'll actually show how to use a vector with the original objects in a second. Anyway, so these are copies, and then so if you want to access one of these copies of the vector, you can basically access them the same way you access an object. Instead, it would, so you can do like that's how you would access an object, but instead you just do airport 0, which is the first index of the vector. And then here, when we clear it and set the size to 0 with this line, the truth about what's happening is that even though the vector is empty, these objects still exist because the vector only had copies of them. Now, if we want to vector the original objects, let's okay, this only has one object, but anyway, that works. So it would be a vector of pointers. Now, you would have this object, and you would pass in the address of the object because a pointer has to point at an address. So hopefully that part made sense. If I repeat it, it's basically you have a pointer to an object, and then address of. Then you would just use it the same exact way you would use a vector, except instead of the dots, you would have that arrow thing. So let me see if I can make it clear. Like, so this is, oh no, it's not loading. Okay. Okay, so this is just like, this is separate from the rest, but basically if I have an integer and I want a pointer, so here we're creating a pointer to an integer. Now we would set the pointer as the address of the integer. Now the pointer points to it. So kind of same concept. You would have a vector of pointers, and we would set the first element as the address of that, and then of course we can add more objects, like whatever. And then so if we want to change some of these, we would just access them by index. And for some reason, that .at sometimes does not work for this purpose, according to my usage of the debugger. So no worries, the square brackets also are an alternative option. So you can do the because the vector is of pointers, you would have to have the arrow instead of a dot. But basically, other than just having the arrow replacing the dot, you're using it the exact same way as you would a normal vector of objects. So yeah, hopefully that made sense. Anyway, we're going to be moving on to section 9. So now it's a little bit more simple. A vector of 7 copies of the object, so no pointers. Here's the object type, and then there's this is the initialization. Create 7 copies of P4. Then of course you can just change each of them individually. So you can do like the second element, or actually that's the third because of in the indexing, and then dot setter. That's basically the same as, like, an object dot setter, except the object is this element. So yeah, I think that's all I have for classes and objects. Thanks for watching. Hope that helped, and see you guys in my next video.